following is the visual demonstration for the roots of a quadratic function. A quadratic function has either two real distinct roots or a single real root with two identical values, or the third case is where it has two imaginary roots. The discriminator's value determines these three cases. Real root or roots of a function is a point or points on its graph where it meets the x-axis. The equation of the parabola in this example is given in the vertex form, which is given here. You can see it here. Now I will demonstrate these three cases visually. Now you can see this parabola has these 2 points where it meets the x-axis. So it has two real distinct solutions, and these solutions are given here using the quadratic formula. In this case, the discriminator is a positive number which is given here. Now I'm going to move this vertex, and you can see these two solutions or the roots are still real, distinct, and they are real because they are really meeting the x-axis at two different points. Now the second case is where when it has a single root but it has two identical values. You can see it here. These are the two values, x1 and x2. Both of them are identical, and in this case the discriminator decides the value of the discriminator is 0. So whether it is here or if I move it here, as long as the discriminator is 0, the two values are going to be identical. The root is a single root. Now the third case is where it has the point, there is no point who is meeting the x-axis or really meeting the x-axis. So they have two imaginary roots because the quadratic function must have two roots. So both the roots, they are imaginary, and in this case the discriminator or discriminant's value is a negative number. So the discriminant is negative number, then it has two imaginary values. Now you are going to quickly see. Discriminant is negative, two imaginary values. Discriminant has positive value, and it has two real solutions. And when the discriminant is 0, it has two identical values, whether you move it here or there. Now, if this one is the case where the two imaginary value of A, you can see it is a positive number. If I change the value and make it to a negative number, then without moving the vertex, we can still have two real solutions, which you can see. Now there are two real solutions on this one. So let me go back and make it this. This is two imaginary solution, one real solution, and if I put it down, this is two real distinct solution. I hope you enjoyed this presentation. For more mathematical concept, you may like to watch my other videos.